So as you guys can see, we have implemented the iOS application and it is working. Right now, what we're gonna do is we're gonna get the same application, the same logic behind getting these things for Android as well. So last time, the thing we have missed was one of the dependencies. One of the dependencies was updated at that time. So the dependencies that we are talking about is view model compose. Okay, this library was the one which was missing. That's why we were not able to inject the view model into our application. Right now, what I have done is I have introduced this dependency to only Android, because since this is an Android related stuff, we are not gonna make this section or this dependency on Android, sorry, in shared module or common module. Right now, what we are doing is we are having everything in uh, Android dependencies only. Give me a second. Okay, so this is the only this is the this is the only requirement that we have, only actually dependency that we have introduced. Other than that, everything pretty much remain the same. Okay, so one thing that I have done is the application right now. It is the main theme application. We have a surface, and we have introduced a surface, and I have created a composable called GitHub Users. And when we are creating the GitHub Users, this composable, what I have done is I have also introduced the view model part of it. And if I go to the view model, nothing has changed except I have created the repository injection in here. So remember, we do not use dependency injections at this point, something like Hilt or Dagger. So for the demonstration purpose, since we only need GitHub repository, which is what we call a shared code, where we can utilize the code section in Android as well as from Android and iOS. So we have the GitHub repository, which is like the data plane. It is not in the Android itself, but it is something we call in the shared section, and it is in the common area. So we have GitHub and we have GitHub repository. So this, we have created one instance out of this. Since it is Kotlin, we can simply call the GitHub repository, and we can get it done in here. So we have the GitHub repository initialization done. We have a GitHub user view model, and within this view model, we can see that we have the GitHub users mutable live data, so we can observe that once we get into our code. So right now, when we are creating this composable, we call this GitHub users. Right now, the view model is injected to this composable. So that's it. So this composable function is aware of the VM model. Okay. To check whether this GitHub user composable is working, we can just simply return a text. For now, I will return a column. Okay. Within this column, I will return a text saying GitHub users. Okay. So if I run this application, the Android application, once again, it should basically simply say GitHub users. Okay, that's it. It's a simple GitHub, simple text message. So what my intention is to get the view model user section in here to show you what are the things available there, and we can show these values uh, within our list view or within our GitHub users section. So we need to have some sort of list. Okay, so in Jetpack Compose, what we can do is we can use something like a for loop. Okay, so we can say for, and we can say uh, I in say, let's say 10 times for the range of 10. I 21 or 2, yes. Okay, so for iteration from 1 to 10, I will take the index as I, and once it is done, I can say I need 10 text in here. Okay, so what if I put this in action? You will see 10 times the GitHub user in here. So that is fairly simple. Now what I need is not it's not going to be something 10 times, but we need it for like the amount of users available in the VM GitHub users. Okay, and we have the value option, we have the size, and this might be an optional, so we have to handle that. Value might be optional, so GitHub users, value. Let's focus on the error that we get. Replace its size, or it's gonna be 0. Okay, if for some reason we have not initiated, then it's gonna be 0. So let's try it out once again. And you guys can see that there is nothing coming in here. So the main reason behind that is we are having the view model. Yes, that is true. But the view model, we are accessing directly the GitHub users and its values. Okay. So if you guys can remember, this kind of approach is not what we call the best approach. We are violating the MVVM structure. So if you want to get the values directly, I mean, whatever the values that have been changed around here, what we need is to observe it. Okay, if you guys can clearly remember, the direction of data flow should be unidirectional. Right now, what we are doing is we are directly accessing the GitHub users. So it is a violation of accessing the values from the view model. So we need to observe these values rather than we are directly accessing those things. All right. So how we gonna do that? We need to say how we gonna access this view model within our application. So we can introduce a variable. Okay, introduce a variable, and we can get the value. So let's do that in here first. So we will say value, and we have, let's say we name it as users, and we can get it by keyword. It is same as what we are doing with the what we are doing with the equal sign and dot value. So we don't need to always say we are accessing value. So what we do is we use the keyword by, and we can say VM GitHub users, and we GitHub users delegates must have get value. So I think the get value is there. What we need is collect state. Sorry, I think the data type that we are having is wrong in the view model. It shouldn't be mutable live data, so we will use something called mutable state flow. Let's see that is available in our view model. So right now we are using what we call mutable live data. I think there is a change in here. Let me check whether we have it. Underscore GitHub users equals mutable mutable state flow, and the current state is gonna be list of GitHub users, and initially it's gonna be empty. The state flow, okay, so we have to create a state. When we are using a state flow, we need to create the current state of the application. So what we will do is we will create a separate data class. We can say GitHub user state. Okay, we can name it something like this, and it's gonna have users, and its type and gonna be list of GitHub users, and yeah, that is gonna be our state. So initially what we have is an empty list. We don't have anything in here. We have GitHub state in here. That is the initialization. Right now, when we get the fetch the values and we want to access the values, let me just code through and explain you guys afterwards once again. And this is gonna be a private variable, and in here we will say, well, state gonna be state flow of GitHub users, GitHub user state, user state, and it's gonna be underscore GitHub users as state flow. Get formatted. Okay. So when we get a value, what we can do is we have something called underscore GitHub users, and we have something called as state GitHub state value equals GitHub state and the repository dot fetch users. gonna be the value, and GitHub state flow works as it is. So we have the state in here, and we can say vm dot state. So state's gonna be as collection as state. Okay, then has no method get value. Let me check whether the architecture the model is we have, well, also we can't say users, and you can say GitHub user state. What's wrong in here? Collect as state, right? State method get value, nothing else can be served delegate. Collect states should be imported. That's might be the issue. Okay, never mind. Now we do not have the access to the column in here. Okay, so we will have just text for short right now. Okay, and we will see whether this is working. Yes, currently working, but we have only the state, and we need to listen to the state changes, and we'll see how we can get the state changes in our application. So yeah, one thing that we will need is the arrangement of state changes. Give me a second. This what we have in here, GitHub state users 0, and we have the editor URL. Let's see this works. There's an error. Let's see the log. Empty list does not have a user. Let's have the size in here to string. Okay, let's run it one more time. There. So as you guys can see, the initial value, we are just not listing all the users right now. If I run it once again, initially, I'm not sure whether, let me arrange this text a little bit so you guys can see clearly. So I will do the changes by modifying using the modifiers available in Composable. So column has something what we call modifiers, and we can use these modifiers to change the behavior or change the UI of these columns, and it is children. So we have what we called under columns, we have vertical alignment, horizontal alignment. Initially, these things are at top start. So what I will do is I will change this states. What we call these things as state in our current column. Okay, so uh, rather than I'm working with the column modifiers like vertical alignment. Okay, let me change the vertical alignment for the column. Uh, vertical alignment center. That means I am changing the current state of this column. This column is gonna be now arranging items in vertical arrangement of the column items will be centered. I'll do the same thing for horizontal alignment. So horizontal alignment also I will center horizontally. Okay. Right now, when we change the status of this column, what will happen is the children which it contains, they will align according to these state changes that we have done. So let me run it once again. Should be centered around here, and I will change some of the states of the text so we can see the changes as well. For example, I will say it was its size, font size. Yeah, font size. I will say like 30.sp. 30 sp points. I will change this and I will run once again. So you guys can see initially the value was 0. Now it is changing to 30 because when we call the API itself, it's gonna give us 30 records by default. Okay. Uh, First, I will get these 30 records into a list. Then what we will do is we will go through the code once again and see how this state and state flow works. Okay. Right now, I'm gonna just print it out. What I can do is I can use something like lazy list. Lazy list. If I'm not lazy column. Lazy column content should be what we call items. Let me check the lazy column documentation. It's always lazy column jetpack compose. Lazy column modifiers. I don't need that. The first thing is the main thing that we are waiting is something called items. So what are the items that we need? Within the items, we can provide items. Items equals, so it's items, and items equal items equal vm dot state dot, so not vm, GitHub users state dot users name. Okay, count is not there. I'm doing something low list, and let me double check once again. Implementation is a little bit different. We have the text. Okay, we have lazy column. Then we have lazy column. We have surface. I think we can basic column items. Okay, there are a few things. Items that is. I think first one is the item property I need to write. So I have the item. I'll just go with text and just say test in here. And for the items section, cannot find with items. Let me go once again. Items. Items equal GitHub user state users. Can't find items, no value. That's strange. We normally have something called item. Oh, let me get column. That might be easy. For I in GitHub user state users, and I will say text. Text will be is I dot login. Let me run it once again. Yep, we get the values in here, but I'll do the I'll make it alignment to top, and also this alignment. I'll just remove this so it will be much more visible in here. I would not need this. I will have column containing text. Let me once refresh again. And you guys can see that I have used the column option, and with the column options, what we have is we have the GitHub users state, and we are using the users out of it. And once I get that, I have a text in here, and the text will just say the login and the password. So this is like the simplest form of UI that you will find. But let me make it more appealing, like this one. So we have in here an image and a row kind of situation going on. So let's create that. So I think we have used a sync image. Content description should be null, and the async image, if I'm not mistaken, for model, I think we have to give the model is what we have to give the async image jetpack compose loading image. Okay, model for model, I think we have to give the URL itself. So I'll rename this as user, so it's more convenient. user dot, we have avatar URL. Let's give it a try, see whether it is working. All the images should be loading. Yes, you guys can see all the images are loading. Right now it is not in a way that we would like to see. So I will just put uh, uh, put this in what do you call, it's like a row. Row is a column, should be a row. Okay, first one is image, then we have a column. In the column we have a text. The first text is gonna be user dot was, I think it was the login and the node URL. Next one is the node ID. Let me run it again. So we have the image and everything in here. So what we need to do is we need to have a padding sort of thing in here. So I will use the modifiers, and I can say uh, modifier.padding. I will use like something like 8 SP or DP, whatever the I think it's only accessing DP, 8 DP of padding for each row. So it will be nicely condensed. Okay. And I think I probably need to give a size for this modifier, modifier dot modifier dot size. I will give like 16.dps in size. So every image is in at the same amount. I think 16 is too little. Let me make it like 100. There you go. So we have 100. 100 is even larger, but since we are not doing anything regarding that, that is okay. And within okay, the 50 seems to be fine, and the column should have a space between the image and this. So what I can do is I can have the column section in here. I have a modifier, and I can say modifier. I can say actually padding. It will automatically say what is the padding that I'm going to work. So I will say at the start, I need some, let's say 8 dp of padding. That means I'm only adding padding to the start of the column. There you go. So you have a little bit space around here. And if I want to change the font for the title and the text a little bit lower in the not if you guys can see in here, the text is a little bit what do you call, the title, the login is a little bit big, and the name is little bit the node ID is so smaller in size. What I can do is I can go to the text, the login, and I have a modifier, or I can simply say size then, because modifier is like the common for every composable, and there are specific ones for text. So we can say something like font size, it is specific for text. Okay. And if there is something like padding and background color, those kind of things are common for everyone, so we can use the modifier. So in here I will say font size. Font size I will say, let's say, I don't know, 32 SPs. 32 SPs, and for the little one, the subtitle, I would use something like 20. So it is not highlighting out. If the font is too much, let's reduce it. Yeah, it seems to be little little bit bigger than I expected. So I will make it like 20 and 16. Much better, but we can do better. I will just make it like an 8. So it is way too small. Too much. Anyhow, you guys get the picture, and we got the values from different section. So let me. I think currently this one is not scrollable at all, since this is a column, and we have wrapped it in a column as well. So I think if I remove the outer column in here, might be able to scroll it. No, still not. Let's see what we can do. Jetpack, compose, column, not scrolling. I think we have to add another property, or we need to wrap it in somewhere else. I think there is a modifier for that. Vertical alignment, column weight modifier. That is the modifier that I am using in. I think this should work. So I have a modifier for this. Column vertical scroll. Remember scroll state, and I need to import weight modifier weight. Need to import. I'm missing something. Weight modifier weight. Wait. I think we have two imports. Compose UI modifier. Compose UI modifier, and this is column. Okay, let's run it once again. It's not available. Can't access column. I think the import is wrong. What I need to do is import. Sorry. Can I get the import in here? No, that is also correct. Not correct. 8 property is not there. Maybe we can align it. Have it in a scrollable view. I'm not sure. I think vertical scroll, will it do the job? Okay, I think we just have to add this modifier, the vertical scroll, and remember the scroll state, so we know where we are. So we got the scrolling going on, and we have the list of users, and oops, where's my mouse? Okay, my mouse got stuck. So we have the same implementation like we had in like what we had in Android. I'm not the UI is not 100% there, The reason behind that is the it is the UI framework that we are using is native for each and every application. So you guys can see that the Android implementation and Swift UI implementation, we can have two different UI libraries, which is native for each and every user interface, but the logic behind it, all the logics that we are having to get the data is shared. Okay, so let me go once more time with the I think I have refactor organize import command. Refactor produce change rename. Remove unused resource. Think remove. Not sure what is the. Let me check. Android Studio organize imports. What's the shortcut? Control Alt for Mac. Actually, I'll see. Let me check. Sorry. I was looking how we can import things, make things organize import. Can't remember the shortcut for Mac actually. One Android Studio shortcut Mac. Control Option O. Control Option O. Okay, there we go. Clean up the code a little bit. So let me go one more time with the view model implementation for Android. We thoroughly went through iOS 1, so we will go with Android 1 for now. So it's easy when we are doing application in here. So what we need is a composable view. Okay, so composable is equivalent what we have in Android XML based views. So composables are like what we see in XML views. We have the composable functions. So I will be creating a function called GitHub user. GitHub users. So this function will list out all the users like we see it in here. In order to do that, you guys can remember we are not going to be using something like we are not going to do the traditional way or the spaghetti code way of getting the data within our views or composables. In this matter, we will be using the view model architecture. So whatever we need to get from the view model, we have created a separate view model out of it. And when we want to get these values, we will just use the view model to get those values in. Okay. And remember, the view model import is coming from lifecycle view model compose. So in order to have this view model function, we need to have the dependencies in our application. So under my Android application, under build.gradle, I have the view model Android X lifecycle view model compose dependency. If you don't have that, you won't work. This was the issue that we faced last time, why we could not get the view model inject into our application. So once we got the view model in place, the injection automatically happens when we call this view model. All we have to do is we have to create a GitHub user view model in this scenario. And you guys can see we have created the GitHub view model in this GitHub view model. So if you guys can remember, we use dependency injection like hilt or to inject our dependencies into our application. Right now, we are not using hilt. We are currently using the plain old object creation pattern. So we have the repository, and the repository is where the data is coming from. And one thing to remember in here, the repository is what we call in here is a Kotlin shared module. That means this repository is available on both Android and iOS. Okay, so we initiate the repository that we need in order to create the view model at the constructor level. And remember, we need to have the view model extended in this class in order to injections happen. Okay, so one thing that we have done in here is that we created two variables. One is the mutable state flow. If you guys can remember in um, in uh, XML version or the hilt or view model injection, we use mutable live data. In here, we use mutable state flow. Okay, so the state flow is coming from coroutine. Okay, so rather than using live data in this scenario, we are using state flow. So state flow is what we can call is another way of observing streams, like what we have used in live data. Live data is also providing state observability. As I mentioned in that lecture, we can use RxJS observers. In here, what we are using is what we call a Kotlin coroutine flows. Okay, so flow is another way of doing that. I find the flow management little bit easier when comparing to other states. So right now, we need a mutable. We will initiate a mutable state flow, and we need to provide the shape of the state flow. Okay, how the states of the whole GitHub user is gonna look like. So I have created a GitHub user state. Okay, so in this state, it will contain all the variables that we need uh, that we need to maintain or retain within the UI state. So if you look at the state right now, I'm only interested in retaining users in the state. But if you need something like counter, if you need something like object variables, those things also uh, can be put it in the state flow, state model in here. So this is like the structure of what are the things that we're going to be storing in this state. Right now we are only going to be storing list of users, and the type is going to be list of GitHub users. So initially I will assign it with an empty list. So initially it will be of value 0 rather than having nothing. It will be 0. Okay, so mutable state flow, we will have this state flow. This is the shape of my initial state. Okay, this is the initial state for the GitHub users. Within the initial state, I will have users. I mean, initial state, I will have users of empty list. That means no users gonna be there. So this is how my UI gonna have. So if I want something like, let's say I need to show variable value of say count. Okay, I can have that as well in here, and the count will be something like an integer. I can have a shape like this. Okay, then I can use the shape in my um, in my uh, in my composable as well. Right now, I am interested in my user state, so I will be just having the count user in here, but I can have multiple state model in here. So I have created a private variable. So the main reason that I am creating this private variable is so nobody, if you guys can remember, um, I was able to access this state using the VM instance that I had earlier on. Right now, by making this private, I block the access from the outside world. So the only way that I can access this state is by using the flow itself. Okay. Without the flow, I can't access. So I am making a barrier of myself rather than I will be able to directly access users. I will make sure that these things are gonna be coming by only observable or value streams. So I create another one called state, okay, and it's going to be a state flow, and the type is going to be the same as the mutable state flow that I am having right now, but this is a read-only state. So you guys can see that out of this GitHub user state, the private variable, I am getting this as a state flow. So this is like the initiation of getting the values, and in initiation point, it is going to be the simple terms. Since this is an asynchronous task that I am going to be performing for the GitHub repository and fetch users, what I'll do is I will launch this data fetching section in a view module scope from Kotlin coroutine scopes. So I will be running this in a different thread or different coroutine in this instance. And so once I get the users using the repository fetch users, what I'll do is I will update my state, which is the GitHub user state, and I need to update the GitHub user state by using this users variable. Since I have only one variable, I can have it like this, or I can use the name variables if I like. Users, and this is going to be users at this point. This is going to be the users. But if I want to update the count as well, I can do that as well. So I say, for instance, I want to update the count as the number of users in this scenario, and I can say val users equal this, and I will say users. I can say in here users. No worries. I have just abstracted. And if I want to update the count in here as the size of the users in this scenario, I can do that. So for some reason, say for some reason, I want to add another 1 plus in here. That means if there are 30 users, the size should be 31 for some weird business logical reason. I can do that one as in here. So GitHub users, the mutable state flow, the value for that, that means the value is going to be a GitHub user state. That's why I am creating a GitHub user state out of this. And I will assign that value. GitHub mutable state flow has a value variable like what we had in mutable live data. We assign that value. So whoever is listening to this state flow changes, this state changes, will get notified. Okay, this value has changed. The state has changed. So it's the simplest, but still bit different than what we have. So this is like a different implementation wise. It is going to be a different one, but it follows the same principles as the MVVM model we had on XML. Okay. So if I go to main activity again, now I need to get the user state in my application. So I have the view model injection happening in here, and I can use the state variable. Okay. And right now, if I want to access the GitHub or the whole state, I can't get it done because I have made it. Sorry, I have made the the GitHub state as a private one, so I can't even access it. Maybe to keep safe, to make things easy to read, I rename these as underscore state. Underscore state. Okay, so we can't access the whole state. That means I can't directly access the value. Okay, I can't directly access the value because right now what I am capable of accessing in this scenario is going to be the state flow. I can't access the value. So that prohibit me from accessing the view model values directly. I can only access those things by using the observable methods. Okay, so I'm using the by keyword, so I don't have to use the values in here. So if I want to if I want the state to be accessed like value dot users, rather than always calling the value function in here, I can just simply call users in here, but I rather than using the equal sign, I need to use the by keyword. Okay, rather than creating this as GitHub users, I rename this as state as well, so it make more sense. So from the VM side, view model, I'm accessing the state. Okay, and I can't access the value directly right now. The value is prohibited. The user's value is prohibited from accessing. I can only access it through the state flow that I am having in here. So I can use state.users. So this is the stream of users that I am expecting. And So you guys can see this is a state flow, okay, not a simple uh, simple accessing. Within the state flow, we have the GitHub state. From there, I can access the users. Okay, the state is the accessing way of the user state is only by using an observable variable in this scenario, collect as a state. So this one is the equivalent of observability. Okay, so if I want uh, since I need to put all the users in here, I will be using something like a column. Okay, and within the column I have modifiers. So in Jetpack Compose we have these things called modifiers. Modifiers job is to uh, change the state, change the attribute of the column, but the modifiers is Modifiers is mainly focusing on all the common things a composable can have. So, for example, a column, a row, a text, all these composable have modifiers like whether what is the padding, what is the background color, all those things. So everything that is considered as common, we will find uh, find those kind of state changes, customization under modifiers. But if we have something only for column state to be changed, we can have those things as well. For example, the I think Control P or Command P. Yes, you can see all the uh, changes that I am entitled to access. So I have the vertical alignment. And I have horizontal alignment. So these things are uh, pretty much specific to a column composable. Okay, so you won't find these things in the text. Text will have its own uh, states, but things are if the things are common, you will find those things under modifiers. So I will say I can say vertical modifiers and um, it was vertical alignment. So you can click on here. So modify is there, vertical alignment is there. You can simply say so I want to change the vertical. I want to say I want to change the vertical alignment in here, and there are vertical alignment can be center, bottom, whatever the things that you like. You can change it from here. So modifiers are the common things for any composable, and there can be states where you can have only for columns in here. So right now we are having we are putting everything in a column, and we have a modifier for the vertical scroll. That means I should be able to scroll vertically. And in order to do that, I have to use the modifier scroll and remember the scroll state. That means where we have change, we need to remember. The reason behind this, remember this scroll state is whenever the state change, sometimes this state change and this column will get re-rendered. Okay, this column get re-rendered. At the point, if things get re-rendered, uh, the scroll might go all the way to the top or the where all the top. That means after a re-render, it's gonna be at the initial stage. So in order to avoid that, what we have to do is we say, okay, have vertical scrolling and remember the scroll state. Where were we? And you have to remember that. Okay, even though the even the application got re-rendered or even either this column or whatever the states that have changed. Anything happens, anything redrawn again, just remember where we were. Okay, we have added that modifier. This one is not that important. It's related to the alignment of. And also we are using the for loop in here. So I can say whatever the users in the state, take those users and loop it, and have uh, one singular user as user. So in this scenario, it is users. Take the old users in the state, and one element of that user, name it as user. Okay, so single item is called user. You can call item whatever. I prefer to have the singular form of the state that I'm interested in. And I would put this in a row in the sense all the components that we see, like we have seen in Swift UI, everything will be in horizontally aligned. So I have a row, and I will modify this row but to have a padding of 8 dp. That means the row will contain 8 dp of padding. And if I want to have like something like um, uh, if I want to have things like how I can see this padding, I can say the background, I can say color, and I can say color dot, let's say, let's use something like blue. So what I have done is I have created a row with the modifier having 8 padding. To see the padding, I would just put a dummy background with the color of blue. So with that modifier, think we should be able to see. Yes, you guys can see that the padding that we have, it's in here. Okay, and this kind of modifiers, you can chain it together. You can have padding like this, you can have background like this, and if you put a dot at the end, you can see all the things related to the modifiers available. These are like all the things available for um, all the things available for the modifiers. So if I want to click event, I can say I can simply say print, and I would say user dot, let's say, node ID. Okay, what will happen is if I go to run section, is it the logcat? I can't remember. Sure, yeah, it's printing things out. I think it is the debugger log. Let's use the debugger log. It's log dot d, and I will have the GitHub as the tag, and I will say user dot login, and I will use the filter for the tag for filtering things out. If I go to logcat again, and you guys can see that when I click on one of the items, it is getting printed out. Okay, so the things like click events, background, those things can be something with the modifier that we can access on. So it's fairly simple and easy what we can do with composable and its composables and the modifiers. Right now, I have just put a simple click event. If I don't want this click event, I can just remove it, and I have the default modifiers. and And yes, so I have a row. Within this row, I will first item would be a asynchronous image, and I have given the avatar URL. I don't need any content description. For long press, I can have content description, or I can just say user dot, let's say, login, something like that. A description like a accessibility option. And with the modifiers, again, I am modifying the asynchronous image. With the modifier size, I am giving 50 dp of size. So the image won't be in different sizes. Image will be always at the size of 50 dps. And the next item in this row is going to be a column. And the first thing with this column is I am adding a modifier. With the modifier, I will say I would like to have a padding, but only the starting section, not all the way around. At the start, I would have a padding of 8 dp, so I have a little bit space between my image and the column that I am about to have. And the column is pretty much simple. I have two text views, one with the login, one with the node ID, and I have given some states for these things. The font size is different on each other. First one is gonna be first one is gonna be uh, um, uh, with 20 SP, and the second one will be 12 SP. So we can see that this GitHub user, we have put it into a modifier, and we are working without an issue. So to make the code much more readable and reusable, what I can do is I can have remove some of these codes into smaller chunks. Okay. For example, one singular row which representing a user and image with the two names. It is represented in this section. So I can simply create another composable rather than rather than putting everything in one single place. I will create a new function, a composable function. I can say GitHub user card. Okay. And what I need to return in this section is this row. Okay, I will put a row in here. Right now, when I remove those codes in here, what I am missing is the user. So I can pass the user in here, and it will be type of GitHub user. Okay. Now, rather than having everything in here, I can just simply say GitHub user card, and I will pass the user which I am getting from the for loop in here. So I have created a separate composable view, and it's gonna act the same. It's not gonna do anything different. But the only thing is that we have a separate composable view for a row and separate composable for GitHub users. Okay, so we can utilize the composable functions and composable um, uh, these composable function to smaller chunks. So we do not depend on um, what we call huge areas. Okay, so we have testability built into these things. For example, if I want to create a preview out of it, let's say I want to preview out the GitHub user card. So I can create a preview instance like what we have seen in the earlier one, and I just need to provide a dummy GitHub user. So when I provide a dummy GitHub user, I can get the preview without running the whole application. I don't need to run the whole application in this scenario. I can just see how the row works, and it gives me more insight rather than running it again and again with the help of preview. I can see how a user would look like. Same goes for composable GitHub users. I can create a dummy VM, and using that VM, I can have the things tested out in my local machine. Okay, without depending on the internet or the view models and repository and everything. The more smaller the composables are, more easy to manage our code. Okay. All right. So up until this point with the Android VM, do you guys have any questions that need to be answered? So Gimhani, Tarindu, any questions? Abhishek, Hasin, any questions? Raise your hand if you get the idea. Please raise your hand. I got the things. Mm, raise your hand if you need further explanation. I need further explanation. I'm not seeing anyone interacting. I'm not sure whether it is okay or not even. Uh, Vidush, uh, Vidush, what do you need help with? You need to further explain, or you are all good? I'm having mixed signals, that's why. What do you need help with, Vidush? Mm, uh, Last time, if you get the idea, please raise your hand. Okay, I understand the concept in Jetpack Compose. Raise your hand. Okay. Don't like, you don't have to be lying. If you do not get it, I can explain once more. Okay, raise your hand if you need um, raise your hand if you need more assistance, if you need any clarification in some point. Okay, I need to know about this. Can you explain about this section? Raise your hand, please, if you need such help. You know, since we are uh, putting a lot of time into MVVM architecture, uh, a bunch of questions can be expected in your final examinations. So we have we have done a lot of investments in here. So expect more from these sections. Okay. Okay. All right. So we created the application in two different in two different ways. The first way of doing it, we were using XML and a hill-based dependency injection and everything, and same MVVM architecture. Then we use a different framework that is also native. But the plus point in here is we are using KMM. So KMM can help with KMM can help with us getting most of the model layer in Kotlin, so the code can be shared. We have the native views and we have the native stuff going on, but the code itself, the UI and everything, we can have it in our most beloved native frameworks. In this scenario, we have the same application in Android, and Android with Jetpack Compose. For SwiftUI, for iPhones we use SwiftUI, and most of the code is shared among the two, so we do not have to do the same model implementation into two different places. Okay, so but remember the limitations. Remember the clear cats on this scenario. If someone is using KMM, there are pros and cons. Know the pros and cons and move on. Okay, if you are new to Kotlin and you are a Swift developer, perhaps you might have some hard time getting involved, but if you have the Android and iOS development within one team, then you can share the resource. The Android team might have to do a little bit of work because they are going to be coding everything in Kotlin, but the iOS users can leverage the abstraction of the model layer. So that's a plus point in a case, but sometimes some people find this hard to continue. Sometimes it is not the optimal way of doing these things, so it will be a little bit different. Okay, so let's hope this kind of implementation is not that hard. What we need to do is we need to just have this MVVM architecture in two different ways. Okay, two platforms, two different ways, and we have demonstrate pros and cons for each. Okay, and the next on the list, I think we have enough solid principles on using MVVM architecture within our application. So if you guys want to adapt this MVVM architecture for something like React Native or Flutter, these concepts are going to be there, and all you have to do is adapt to the existing frameworks and existing libraries, existing stuff. Then you guys can work without an issue. So in Flutter, you have the state management or the MVVM model management, something using what we call blocks. Okay, so we don't call it MVVM directly, but it is these it is what we call the similar implementation. So you guys can apply these things without an issue. So we build the same, we can build the same application in Flutter, have the same concepts, and we can work without an issue. Okay, so there are different architectural patterns sometimes you will find, and not only MVVM, but like some things like clean architecture. There are application architectures like clean architecture, which is something similar to MVVM. There is MVP, MVI. There are a lot of architectures around here, around mobile frameworks, web frameworks. So uh, we can't expect to learn everything, but all the concepts are trying to do a separation of concerns. We always try to um, separate our business logic and our UI into two different layers, so we can easily manage those things. So we have the same implementation in here in our view model. The view model is not depending on anything, anything other than Kotlin related stuff. Okay. Um, um, so there is nothing related to Android in here. So we can independently test these things. Okay. So when you are working with another pattern, maybe clean architecture, MVP, anything, make sure you have these separated concerns. Okay, you don't incorporate everything in one single spaghetti code. You have the UI layer separately, you have the business logic separately, you have your data layer separately. So most of the time, um, if you look at the things like clean architecture, they follow the same thing. Okay, so it's gonna be easy for you guys to adapt uh, uh, by following at least one of these implementations. And the reason behind following one of the design patterns is you get to see why this is important, and what are the benefits of doing such a thing, and what are the what are the what are the pain points of doing such a things. Okay, so especially you will have a clean architecture for sure, clean separation of layer. That is a good thing. When your application grows, it will be hard to maintain all those things. But right now, with these architectural patterns, anything, any sort of way, MVVM, clean architecture, MVP, whatever, you have the separations, and you can scale up to huge applications. But I'm not saying that this is a silver bullet for everything. At least some pain points will be reduced by using these things. But remember, when we are using the MVVM architecture, we are at the added complexity for some things, especially with dependency injection and all those things. But there are solutions for that as well. But it add a little bit of complexity layer to our application. We have to balance it out whether it is worth or not. So I think most of the time these patterns are like highly tested, used in industry. So we are safe to say that these patterns will bring us more efficiency to our code rather than having having disadvantages. Okay, you might find a random guy on internet saying MVVM is stop using MVVM or something like that, but they might have their points. Of course, you guys have to see whether those points are valid, whether those points are applicable for you. And if they are, try to get the good things. If they suggest something alternative, something more easy, take a look at those things as well. Okay, So do these things in your um, own research and work on these things as you might have seen. It's going to be really easy if you know the basics behind these things. Okay. And one other thing that I have seen recently with KMM is that let me see whether I can KMM compose um, multi-platform for iOS. Okay, which is going to be something like what we are doing in Flutter. So compose multi-platform on iOS. So what happens in here is as I get the idea. So we create the composable views using Android, and the same composable view can be used with iOS as well. Okay, so that is like sharing the UI itself. So what we are seeing in our Android application right now, what we see is this. Okay, this UI that we see from Jetpack Compose, and the UI is a little bit different in here. It's more of a things with Swift UI. Sorry, but the advanced the team behind Jetpack, the Kotlin multi-platform, they were able to get Swift UI and UI kit things into Jetpack Compose. Okay, so the Compose view work without that much of hassle in your Android application as well and into iOS application. So more or less, what will happen is you will have less time spending on more of time you will less time on UI design as well. So this is kind of like an alpha level at this point, if I'm not mistaken. Yeah, it is in alpha as of May, but um, mm, as is this point, there it might be stable, but not sure. So you guys can check out the sample projects, demo applications. They are not only the model layer, business layer, and everything that we find on an Android application can be ported into the Swift or iOS application. So basically, what we are getting is something like Flutter, but in the native way. Okay, so you guys write the compose view and everything, and the compose view will be automatically converted to something that works in iOS as well. I'm not sure how how much this is stable at the moment, but you guys can try it out, give it a try, see how much of less code that we need to do. So if you take a look at our project structure, and if you look at the iOS application, with the iOS application, we have this GitHub implementation. We have the view, the same thing that we have written in GitHub user view, same as what we have seen in Android, and we have the view model. All of these things can go away. Okay, all of these things can go away if we introduce um, Compose for iOS. Okay, everything will be in Compose. There are things that you can do. So UI kit embeddable in Compose. You can do that as well. So within Compose, you can have iOS specific stuff as well. you can mix and match as you like. So interoperability is something that you can do. So you can see in here the example. This section is compost view embedded in Swift UI, and this section is floating Swift UI text view. So you guys can mix and match between these two, and you won't see a difference whether you are using the native one or um, you are using the compose view. Okay, so that's up to your imagination. You can mix and match both UI frameworks, but if you like to stick with the native ones, of course you can do. If you like the unified view, you can use the compose view in here. I'm not going to talk about this new alpha releases thing, but it's better if you guys know these things exist and you guys can see how fast these things change in our day to day. So earlier, KMM came as something like a sharing code. Now they are moving towards even further by introducing things like sharing the view itself. Okay, it's becoming more of a hybrid platform. Okay, but you have the native capabilities and all those things like we discussed in this lecture series. But uh, if you are if you have more customer, if you need more integration, more code sharing, more view sharing in this scenario, you can even achieve that as of now. Okay. um, so any questions up until this before we wrap up the MVVM architectural stuff? Okay. All right. So um, uh, we have covered Flutter implementation on our last lectures, right? I can't remember whether we covered Flutter. Did we cover Flutter last time? What were the topics that we talked? Was it only an introduction, or did we go beyond the introduction? Anyone can remember what were the things we covered? I do have the playlist if I'm not mistaken. Let's see. Mobile computer technologies, right? No, this current one. Was it a 201? Android project structure, fragment. We talked about Swift UI. We have done introduction to Flutter, right? If I'm not mistaken. Mm, yes, map implementation. We have covered REST API. Okay, that's great. Mm, mm, right. Okay. So the next topic for application development is something completely different. So mm, it's more of a emerging technology at the moment. So let me get these slides back on. So it's anyone here have heard the term AR VR? Anyone here have worked with AR and VR? Now raise your hand, please, if you have worked with AR and VR. I have encountered at least AR VR. Slides. Raise your hand if you have encountered with AR and VR. I have seen AR and VR. Nobody? Anyone have an idea what's AR and VR is? Okay. Hasin, what sort of application that you have seen? Like some example, I have seen this, seen that. What are the things that you have seen?
I have seen some application using AR that implement virtual objects in some areas, some kind of.
Okay. Yeah, yeah. So do you know the difference, or anyone else? Do you know the difference between AR and VR? Because we will be looking at by AR. Anyone have an idea about AR? And what is the difference between AR and VR? Augmented reality and the virtual reality. Nobody?
uh, Augmented reality, in augmented reality, the virtual object is displayed on the real world as it was in the real world, in the using the real world weapon, and the VR it is completely virtual, like everything is not real, but
Yeah.
it gives us a feeling that as it is a real world.
Yeah, correct. So what's the what we have defined in here? The augmented reality is a concept where we place things, let's say objects in this manner, objects in the real world. Okay, but it's not like I am picking up a bottle and putting on top of a table. Okay, no, we use uh, some sort of a device. In this scenario, maybe a mobile phone. We use the mobile phone to uh, to scan the real world. Okay, to scan the real world, we have several sensors built into our mobile phones, especially with the smartphones. We have the camera. Camera is a sensor where we can see the real world. Okay, and when we capture the real world through our camera, let's say, for example, we find ourselves on top of a table, and when we look at the table through our phone using our camera and our display, we will in reality we should be seeing things physically located on top of our on top of our table, right? But using augmented reality technologies, we can enhance that view. We can enhance that view. We can put a virtual object on top of our table, and we can say, okay, in the what if we have this virtual object on top of our on top of our application, how it should look like. That's kind of thing is what we call the augmented reality. Okay, I'm not sure whether let me show some let me get some demonstrations in place. So you guys have seen the augmented reality, but not identified it as augmented reality. One other thing related to augmented reality is if you guys have seen face filters. Okay, where most of you guys have applied face filters within your phone. So what it does is it scan your face, okay, using the camera, okay, using camera, and what it does is apply something that is not there, okay, on top of your face, on top of your head, on top of your upper body. They place like a hat, okay, so they track your head movement and knows where your head is, and they place a hat on top of that. So that kind of thing is what we call an augmented reality application. Sometimes uh, there are things like what we can see, like sunglasses put on sunglasses uh, in your on your face. Okay, so you have things like virtual tryouts. Maybe you guys have seen those things in real life. Uh, it's pretty much easy and simple. You guys can see that. Um, so let me mute my phone. I'm trying to get an example of this. Can I share my screen? I think I can share my screen. Give me a second. I need to enable it. So this is something what we call, you guys can see my phone. Google have these zebra. So things like zebra, let's say AR in this scenario. Okay, so these are like the AR libraries that we can find out in internet. Let me get, no, I think let me stop sharing first so you guys stop sharing. Give me a second to get it in order. What was it called? Locked. I was playing around the technology with my son, so that's why I'm trying to get it in here as well. So yeah. So blending the real world things with the existing world, we can have a little bit of enhanced experience with our augmented reality. So the usage of AR is much more complicated, much more fun sometimes if we can put things in place. So there are like 3D models that we can put it in augmented reality. I think it is loading right now. I think. View in augmented reality. I'll show you this. Yeah, view. Sometimes it is coming, sometimes it's not. Occupying AR. So with the AR technology and everything that is related, it's a thing that we can enhance our view. But remember, it comes with certain limitations, especially with the device. Okay, so we can't expect each and every device out there, every smartphone is out there will be supporting these kind of things. That's because having some sort of augmented reality within our device, within our environment, it takes a uh, lot of computational power, uh, lot of things related to a lot of things for processing. So when those things come all together, what will happen is your normal phone might not be capable of doing such a thing in the real world. So your phone should be um, very much capable of handling these things. Sorry, I can't get to work with the AR things for my phone, but as soon as I find it, I will share with you guys so you guys can experiment it. But as I as I explained in here, augmented reality is not for all the phones out there. Okay, there are certain limitations. Limitations come by processing power, first of all. So if I say AR enable devices, and there are a list of phones which are like supported by manufacturers. Okay, you can't expect to have your phones, if it is a little bit on a low end grade, to have it in here. Okay, so we have some uh, uh, some of the phones, and there are some APIs which are supported, some APIs are not supported. So not all the capabilities that we require is going to be available if your phone does not have these sensors with this processing power and all those things. So if, for example, some models only support OpenGL and supports GPU resolutions up to this with this um, resolution, and there are like certain limitations that it will come. Not all the phones will support high definition, but they will support few resolutions and all those things. So make sure before you use AR and VR application, before you develop something, at least have a supported device. Of course, you can test these things by using emulators. That is possible because most of the time the machine that we're going to be using to develop, they have a lot of capabilities compared to phones. So make sure your phone is supported and they have the capabilities for all the things that we need to AR in order to work. Okay, so AR technology is not something new. Even though we are using day-to-day activities, we might not have thought it was as AR. So you guys can see this is like one of the AR implementations. Okay, this is gonna see through a phone, obviously, but what AR does is it's creating something on this table which is not there, but it's in sometimes we can even interact with these objects, but not mandatory. But you guys get the picture where you guys you can build something out of thin air. So this is one of the examples that most of the time we get in AR and VR, that is object placement. So one of the core things that you will see, like if you have a free space in your room, how would it like to have a lamp in here? How would it like to have a chair in here? And change the colors and change all those things, and how your room would look like if you have these things in place here and there. So it is something that that is available that we can do, and sometimes things like showing more information on top of these things is also possible. And let me show you one neat example. An AR wall paper, if I'm not mistaken. Yeah, cool. It's a nice experiment done by AR team. I'm not sure whether I have the resource. Okay. Think it's removed from where it was here somewhere. But one other thing that you guys might have seen, the usage of games. That is a huge part when it is coming to AR and VR stuff, especially with AR. I'm not sure whether you guys can remember there was the application, what it was called, Pokemon Go or something like that, where you can have like demon sort of playable characters in real world, and it went crazy uh, uh, throughout a few years ago. And you guys can see these things out in the real world, where you guys can capture these monsters and you get rewards for that. So that's kind of game implementation is something very popular in this space. So you might have looked at those kind of games, and we can actually interact with the real world and have some things shown at the same time. So entertainment purposes, we can have these things in our applications as well. So this is for like one of the game promotions that you will see. And in the real world, you can place these objects, you can interact with those objects. That's kind of immersive world is created out. Okay, so these things can be achieved using AR technologies. Okay, so we have talked about the usages, where you can say in beauty, where you have filters and all those things. Other things like object placement, like for retailer detailments and all those things. And we have seen in the space of games, and very recently I have seen I think Google Maps have some AR capabilities. Google Map AR, there was like a Fox or something like that, if I'm not mistaken. So this is like their demonstration at the time. So when you are using Google Maps, normally you would see something like what you will see in here. You have the direction and all, and when the AR kicks in, when the AR is placed into our Google Maps. So what will happen here is rather than telling what to do, you will see these kind of objects in the real world. Yeah, it's gonna show, okay, go to this way. It shows the navigation rather than saying, okay, go here, go there. You will find these augmented reality placements put in, so you guys can see what's the location. And you guys can see on here, they do a real-time analysis, and if you are interested in sandwiches, you can place advertisements in here. So that's a huge space, and you can see the pet animals like this. They can show, okay, let's go this way, let's go this way. That's kind of a like an interactive way of getting things done. So AR is more of entertainment, more of informative, and sometimes interaction is huge. So especially with the potential use cases like advertisement, product placements, and you can think more in this space since it is new. So if you have the next big idea that help with you to grow within the emerging market, try it yourself. To try it yourself, what we will do is we will learn a few basics with the AR and AR platforms. What are the things that you should know? So there are like a couple of things that we're gonna be working with: the partial APIs, depth APIs, anchors. So we'll talk about all those things in the lecture series. What are the basic concept behind building such a thing? Okay. So the first thing in AR technologies, we should have these key features with AR application. We should know these things in terms of AR application. So, and one more thing that I should mention, that AR implementation has like two different variants with the two rival platforms. For Android, we have something called AR Core, AR Kit, AR Kit for Apple related applications. So what we have so far seen some of the use case of AR Core, but if you want to develop native kind of things with iOS applications, you can use the AR Kit. Okay, so these two frameworks, what will they do is they will help you to build AR VR application, because there are a lot of things that should happen in the background in order to power such an application. So you can't build everything from scratch. Okay, there are certain things, certain functionalities these frameworks support us. So we will see what are the things AR Kit and AR Core gives us with their frameworks, and how these things will help us in the first place to develop applications. Okay, so we will be talking mostly with AR Core. We will not go into much detail with AR Kit, but the concepts behind those two frameworks remain to be same. There are a little bit of difference on some frameworks depending on the hardware capabilities. For example, Apple has things like LiDAR. So they have special inputs that we can use in some of the AR applications. So those things might not be available in AR Core, because LiDAR is not available in the Android phones that we will find there. So in order to keep things simple, we will just talk about AR Core, because a lot of you guys can access AR Core related stuff, or you can test these things out in your Android phone if it is capable. If not, always you can use simulators to run. Okay. The first key features that AR Core will give is motion tracking. Okay, so AR can detect and track visually distinct features in the real world to understand the position in space. Okay, so as I mentioned earlier, when we are doing object placements, when we want to interact with the environment, the first thing that we need to do is we need to understand the position of each and every object or distinct features in the real world. For example, let's say we have a water bottle on top of your table. Then the table is a distinct feature and the water bottle is a distinct feature. So we need to exactly understand where the water bottle is in this given space. In the table, we should map, okay, at given XY locations, the water bottle is on top of the table, okay, and we need to track. So even we move away from the bottle, even we move away to out of area of the view scope, current view scope, we should be tracking where it was really situated in the current context. Okay. Sometimes the viewpoint where we see throughout the phone can be different, can be out of range, can be very huge depending on your camera and uh, sorry, the area it covers. But whatever we move, whatever we point through our camera, we should track the different visually distinct features, and those features should be able to distinguish between each other. Okay, we have let's take another example. We have a table. On that table you will find the laptop, and you will find a bottle, and you will find a smartphone. So when we are doing the motion tracking, when we are doing the initial scan for the environment, what should we do is we should be able to say, okay, there is a laptop at this XY coordinate, there is a water bottle at this XY coordinate, and there is a phone at this XY coordinate. Even though we move away from the viewing point of that location, we should clearly understand where those things were and what are the XY coordinates. So if we were to develop something like that, we need to build it from the ground up, the Cartesian plane and motion detection, and we need to detect also visually distinct features, like we need to detect the bottle, we need to detect the flow or the table flow. Laptop phones, we need to differentiate, identify those things, visually distinct features. So it's going to take a lot of things, a lot of time. We probably might need AI models to track these things, to distinct the features, to calculate the distance. It's a lot of works going on. So what AR Kit does, or AR Core does, they provide support for these things out of the box. So we don't have to worry about those things. The next thing is the environmental understanding. Okay, so we should be able to understand flat surfaces or horizontal surfaces. So for example, we have a flat surface. Let's take the example of floor. And at the end of the floor, you will find a wall, which is like a vertical flow, which is in terms of the flow, it will be 90 degrees 90 degrees difference between flow and the wall. So environment, by understanding the environment, what it should do is okay, this is the flow. We I can place object in this flow, and this is a wall. I can also put object this in this one as well. But since the flow is a horizontal one and the wall is a vertical surface, when we putting the object, it should be realistic. Okay, if we put a water bottle, if you put a water bottle on the table, it should remain in a certain way. If you put the same object, if you like to put the same object in um, in vertical place, it should not be the same as it is. So let me show you guys what I mean, at least what I'm trying to explain in here. So can I share the camera of this thing? Okay, camera. So hope you guys can see me. Can I change the camera? Apparently not. So for example, let's take this water bottle, which is in this flow. Okay, this is a vertical flow. And if I think this is a virtual object, so if I place it on a vertical flow, it should display like this. Okay, and if I got a wall like this, okay, and if I try to place this in a wall, if it is placing like this, it does not make any sense. Okay, if I am about to put this water bottle in a vertical space, it should be something like this. It should have a different angle like this. If I put it in a flat surface, it should be looking like this. And if I put in a vertical one, it should be look like this. So the environment understanding is crucial when it is coming to uh, the application that we are building. So we don't have to do these things out of our own. What we can do is we can simply ask ARCO to do the environmental understanding. So we don't need to work on that. Okay. And the third thing that ARCO is good at, ARCO understands the lighting of the environment, allowing the adjust colors to give virtual objects and increase sense of realism. Okay. So in this scenario, what we are talking about is the light estimation. For example, we are putting a virtual object on a surface. Okay. Let's say, for example, the object that we are trying to put is on a dark room. Okay. So we are trying to put the virtual object in a dark room. So when we are doing that, we can't have something like we can't have an object which is glowing, which is out of ordinary, to have something reflected on a dark room. So if the room is dark, the object that we are going to put should be a little bit darker in tone. Okay, so it's bringing more realism. But if you are in an outdoor position, and if you put a very dark and not very gloomy application, then it does not reflect the lighting on the real world. Okay. Uh, uh, so we should have uh, uh, those things considered when we are putting those things. So when we are doing applications with ARCO, so if the environment is having more more lighting in the application, or more lighting in the background, the application will looks more more lighter. If the application is in darker, it will be in dark. Okay. Also, we need to consider the fact the light direction. Okay. Say for example, the light is on top of you, but when we want to illuminate something to give the 3D and realistic view, you can't have the illumination from the bottom. Okay. If we are illuminating from the top, we should illuminate it from the top, otherwise it will not be good as it looks. So let me show you what I mean by the light estimation. So you guys can see within this example. So the light direction, direction of light, it is mainly from top. So we guys can see the top is shining a little bit rather than the other, and the light is brighter in this scenario. So the object that you see in here is brighter than what you see in the left side. So if the room is light, the lighting on the object itself is a little bit more lighter. But if the room is dark, the object itself look little bit dark. Okay, and the next thing is the shadow direction and all those things. You guys can see that if you are placing something like this, the shadow should move according to the light direction. So that is something we need to consider. So one other thing that you will see in here, you guys can see that uh, if the uh, uh, if the light, the shadow that we are seeing in this object is on it is behind this object. So light is coming from background. So the luminous point or the area which it should illuminate is the front. Okay, the back won't have that much of lighting because the lighting is coming from the front. The back would be in dark. That is the real life light estimation. So in this scenario, you guys can see the back is a little bit darker. And if you look at this example, right next to it, the shadow is on the opposite way. So in realistically, the area that we see it should glow more, but if you go and look in the back, it should be less luminous because the shadow is casting the other way. So these kind of light estimation is done for us. Same goes in here. The way the shadow cast. So in here you can clearly see the back area of this is darker. The front area is a little bit lighter because the shadow is casting in a diagonal way to this object. So light estimation is one of the most fundamental things the AR core does for us. Okay. So these kind of things we should remember. Where light reflects, where light emits, those things those things are handled for us. So we don't need that much of care in our application. So this is one of the example of object placement. You guys can see within this figure that there is a flow in here, and when the flow is scanned, you guys can see these little weird tracking points or distinct points. This is how the application scans, and once the flow is scanned, once they recognize the environment, once they get the understanding of the environment, the surface is detected somewhere else, and we can place object in here. So you guys can see in a flat surface like a flow, the object is in this way. But if you understand the environment correctly, and if you place the same thing in here, it should place in a different direction. Okay. And I think depth introduction is where you understand how far each object with the one another. So we should have a understanding of the depth of the application, the depth of the pointing that we do. So those things are like built into the application. So we are not making things look weird. Okay. So in here, you guys can see the placement environment understanding is also done correctly. If we place these virtual objects on floor, they will be in a vertical way. But if they put in a vertical position, the object is in a horizontal way. So that is like the depth detection and how we can detect things in real world. So make sure make sure these things are done by your AR or AR framework that we are using. Augmented image. So this is one of the this is the capabilities. One of the capabilities with AR AR is to replace with replacing objects in real world. For example, the way the face filters work, they replace our face and its features with something something out of not real. Okay, so we can do the same thing in here as well. So in order to do that, we need to have differentiable objects in the real world. For example, our face are very unique. We have differentiable objects. We have our nose, our eyes, lips, and all those things. So in that manner, we do not need that much of differentiation should be going on. So in that scenario, we can have things like um, um, uh, reusable features or replaceable features in our face. But in here, there are certain images like this. These are not very good in terms of replacing. But if you take the Earth, which contain many unique features, then we can replace. Otherwise, if you have the same sort of features, the AR or the framework will not be able to understand the image itself and do the replacement. But lucky for us, when we are talking about things like our face, we have so many different features. We do not have the same features that much within our face. So in that in that scenario, we are good with the augmented reality. So the motion tracking, environment understanding, and light estimations. So these are like the core components. There can be more. At least these things should be covered by your AR core platforms or whatever things framework that you are going to be using. So one other thing you should know in terms of AR, there are like theoretical parts or things that we need to do. Things that you should know, like the things we are talking. These are like what do you call technical terms that you should know. So when we are talking about an AR application, these technical terms come and go. These technical terms that you should know in some point. Okay. So first thing that first technical point that we should know is the feature points. Okay, what do you understand by a feature point? When you move around with your device, of course, when you are dealing with the AR enabled application, you will be moving around with the device. So you will have your AR core use camera to detect visually distinct features. Okay, when you move around your surface, when you move around your area that you are trying to improve using AR, you should be able to detect visually distinct features. Okay, we can do that. We can our eyes are trained in a way we can visually detect anything as of now, at least what we can see. So if I look at right now within my desktop, within my working table, I can see a bottle, I can see my laptop, I can see my phone, I can see my monitor, a mouse, a keyboard, my purse, and I can visually distinct these things by simply looking at few things. Okay. Uh, uh, so uh, so uh, so the main things that we need to do is our eyes is good at detecting these things, but uh, our phone or our application is not gonna be doing that much of intelligence task by a small processor, small memory, small visual aid, that kind of things. So what we can do is in a case like this, there are AI models which are like there are like um, there are like things with these feature points, and our phone is um, feature points that your machine, your camera can detect, but based on AI algorithms, based on the training that they have, especially algorithms like convolutional neural networks, CNN, those kind of techniques. By using those techniques, yeah, a camera or its AI process can distinguish these uh, so-called visually distinct features, and they can detect. Okay, so the feature points that you will see in an application, you will see these different points that what we have at this point will be things that you can understand in the real world, where you can differentiate. So the feature points that we are talking in here is visually distinct features. Okay, as I mentioned, uh, a mouse, a phone, something like that. Okay, um, and and there is the feature point detection. The camera is one of the main things that we can use to detect the distinct features by using colors, by using the area of the place, this kind of thing. But there are special features like depth detection. Okay, where you can see the depth. Okay, you can it might have the same color, so it's visually not distinguishable, but if you take the depth, it will have a little bit more details than you think. So there can be special sensors where you can detect feature points, but it's not available on each and every phone that we have. Okay, the sensors should be available. All right. So what I'll do is I will talk about the other three in upcoming lectures, and we will get into more into the AR and AR stuff with upcoming lectures. For now, let's take these key features what we have talked about, go with the AR core or AR kit documentation, have a little bit idea on what's going on there, what are the other things that we have missed, get a good knowledge on that. We will talk about the posts, plane and anchors in upcoming videos. Okay. All right.